Okay, last week we started this topic, which is about the redox reaction, in which involve oxidation and reduction. Oxidation means it's a loss of electron. Reduction means it is a gain of electron. Oxidizing agent help in oxidation by itself it is reduced, and reducing agent help in reduction by itself it is oxidized. We discussed the chemical equilibria or a balance in a chemical cell. That basically what happened, the more reactive tend to lose electrons, so majority of electrons are on the surface of more reactive metal, and like charges repel each other. So as they repel each other, the electron have energy, they force each other to move in the circuit. As they move through the circuit, this movement will provide energy to the electron, or each electron have sufficient energy, which we call voltage. This is when we are using a two different metals, we call that as electrode potential of a cell, because like here we are using a zinc and copper. So zinc is responsible for energy of the electron as well as copper. So resultant energy which each coulomb of a charge will have, that is the voltage or electrode potential produced by the cell. But if we need a standard electrode potential, so if we need a standard electrode potential, so standard electrode potential is when we are comparing this with a standard hydrogen electrode, because hydrogen electrode, basically electrode is not made up of hydrogen. Electrode is made up of platinum, at which the hydrogen molecule can dissociate into hydrogen ion, or hydrogen ion can discharge and from the solution to form hydrogen gas. And hydrogen ion, from where we get these hydrogen ion, is from 1 molar solution of hydrochloric acid. Why we call that as a standard electrode potential? Because it is done at standard condition, that the solution is of 1 mole, standard atmospheric pressure, which is 100,000 Pascal or 1 atm, and temperature is around 298 Kelvin or 25 degree centigrade. These electrode potentials, whenever you will use the data booklet, all the electrode potentials are given or shown to gain electron. Like the ions or atoms are gaining electron, so all the electrode potentials are given for gaining electron. But if an electrode potential is negative, so what it means, it means the natural tendency is to lose electron rather than gaining electron. So example, here you can see for lithium, the standard electrode potential for lithium ion to convert into lithium atom, it is given minus 3.03. So what it shows that natural tendency is not to convert or not to change from lithium ion to atom. It is opposite, that lithium atom will change into lithium ion. So lithium atom will change into lithium ion by loss of electron. So all the electrode potential are given for gaining electron. So Li, which is +1, take electron and change to lithium atom. This electrode potential is minus 3.03. But so opposite will be 3.03 volts. So when we compare, because this is more feasible, this will occur easily as compared to the first one. So basically what happened, lithium atom has a tendency to lose electron and change to lithium ion. When something lose electron easily, what we call that change as oxidation, or we can say it will be a reducing agent. So lithium here, which has oxidation, is a loss of electrons. So lithium atom, for lithium atom oxidation occur, or it help in reduction by itself, because reduction is a gain of electrons, so it will lose electrons, so substance can gain electron. So when we have negative electrode potential, so the elements which are on our right hand side are good reducing agents. And if we have positive electrode potential, like if electrode potential is given positive, say any element M is there, it has gaining electron and convert into atom, and the electrode potential was given say 2.01 volts. So if it's a positive, it means this is feasible. If this is feasible, means this ion is having a tendency to gain electron. When something is gaining electron, so what we call that as a reduction, or it is an oxidizing agent, but not that element. That ion is a good oxidizing agent. Oxidizing agent means the substance which help in oxidation by itself, it is reduced. So working out the electrode potential of a cell, example, if we are using a cell which consists of magnesium and copper. So if it consists of magnesium and copper, and we draw the or shows the cell, so magnesium electrode is there, then copper electrode, a salt bridge, and we have a solution which contain a magnesium ion and a solution which contain a copper ion, and the concentration of each solution is 1 molar. So 1 mole of magnesium ion is there and 1 mole of copper ion. But for example, just an example, say it was Cu2SO4. So I will, in that case, one molecule is giving 2 copper ions in that case. So what I will do, in that case, I will not use 1 molar solution, I will use half molar solution. Why half molar? Because if I have 1 mole, then it will give me 2 moles of. So if I use a half molar solution, so I will get total 1 moles of copper ion. That is just an information only in that case. If it is giving the ions in the same ratio, then we will use the same concentration of molecule, that how many ions we need. So example, the electrode potentials are given for magnesium, ion to gain electron and change into magnesium atom. The electrode potential is given minus 2.37. And for copper ion to convert into copper atom, the electrode potential is given 0.34. So you can identify, because if it's a positive change, positive higher electrode potential, the best way to understand the fact or write this is the substance for which reduction, electrode potential for reduction minus electrode potential for oxidation. Because the higher one, reduction will happen, and the electrode potential, if it is higher value, even both are negative, but the higher one, like example, if one value was 2.37 and one value was minus 0.34, so both values are negative, but which is a higher value? This one is a higher value, so means this will be a reduction, so this the other one will be oxidation. So electrode potential for reduction minus the electrode potential for oxidation will get the cell voltage. So copper ion gaining electron change to copper atom, so this is feasible, so reduction. This is a high negative value, so it means magnesium ion will not change into magnesium atom, opposite will happen, magnesium atom will change into magnesium ion. So for this equation, reduction does not happen. All the reduction electrode potentials are given, but for this case, oxidation will happen. So reduction minus oxidation, reduction was 0.34 minus oxidation is minus 2.37. So when we substitute these values, we'll get the voltage produced by this cell will be 2.71 volts. And what actually happen if there is a flow or the movement of the charges. So magnesium atom will go inside the solution as a magnesium ion. The electron, like charges, repel, so they will travel through the circuit if the current flow, and copper ion will gain electron and change to copper atom. When we represent the cell notation, when we use, so how we represent a cell notation, electrode on the left hand side. So which electrode is on the left hand side? So we have magnesium electrode on the left hand side, which is solid. Then what are the ions present in the electrolyte? Magnesium ion is there, so that is magnesium ion, aqueous. Then this is the symbol for the salt bridge. You can use a dotted line. Some books dotted lines are used, some books continuous lines are used, so both ways it is correct. Then in electrolyte, what ion electrolyte contain? It contain copper ion and it change into copper atom. Is it clear? Calculating. So sometime you have to calculate the electrode potential of a cell. Sometime you have to show the direction of electron flow or what basically happen in the cell. Yes, electron are moving from more reactive metal electrode to the less reactive metal electrode, if there is a flow of the charges. So more reactive is refers to negative electrode and less reactive is refers to positive electrode. So magnesium is converting into, you can also use a simultaneous equation to solve this. A magnesium is converting into magnesium ion by losing 2 electron, and copper ion is gaining 2 electron and change to copper atom. The electrode potential for conversion of magnesium to atom to magnesium ion was, because magnesium ion to magnesium atom is minus 2.37, but this is the opposite change, so it will be positive 2.37, and copper ion gain electron convert into copper atom, so that is 0.34. So simultaneous equation, I want to remove electron, one side electron is on the right hand side, another one on the left. So if I add two equation, electron will cancel with electron, so equation will be magnesium atom reacted with copper ion and convert into magnesium ion and copper atom, and the final electrode potential will be 2.71 volts. And keep one thing in mind, even the sign represent the movement of the electron. Using the electrode potential sign, you can identify for which substance reduction happen and for which substance. Yes, you can identify from signs as well. But for example, if there was an equation, if I say magnesium was reacting with magnesium was taking 2 electron converting into magnesium atom, and the electrode potential is given minus 2.37, and for silver is plus 1 taking electron, electrode potential example is given 1.1 positive. So for which one reduction happen, for magnesium or for silver? Reduction. So for silver higher, so this will reduction happen, oxidation. But if I want to write equation, because the equation must be a balance equation, so, and if I need a cell voltage, if I need the total cell voltage, that is the reduction minus oxidation. Just remember from redox. So if you remember from redox, red is coming first and ox is second. So reduction minus oxidation. This is a reduction. So 1.1 minus oxidation is minus 2.37. So it will be 1.1 plus 2.37. This will be 3.37. 3.47 volts. But if I want to write the equation, for writing the equation in this one, in when we have a magnesium and a silver, so equation must be balanced as well in terms of loss or gain of electron. So basically, if it's a negative, it means opposite happen, that magnesium atom converted into magnesium ion by loss of 2 electron, and silver ion, uh, take 1 electron, change to silver atom. But if I add, this was electrode potential will be 2.73, then this is 1.1. But when I write the equation, because number of electrons should be same, the loss and gain, so I multiply this equation by 2. But what is the mistake student used to make? They multiply the voltage also by 2. That's wrong. Why you should not multiply the voltage by 2? Because this is a standard electrode potential, and standard electrode potential is written for 1 mole. In equation, we may have 2 moles, 3 moles, or 4 moles, but actually what we are doing, we are writing for 1 mole. The equation is according to the balance part. Equation is not necessary that it is according to 1 mole. It can have 2 moles. But the voltage of a cell is according to 1 mole. So when you are multiplying, making the number of electrons same, do not multiply the voltage by anything. Otherwise, your answer will be wrong. So here what happened? Magnesium reacted with 2 silver ions, changed to magnesium ion plus 2 silver atoms. So this is a balance equation for reaction between magnesium and silver. But the voltage, electrode potential, or standard electrode potential for this cell will be 3.47, not like 3.47 plus 1.1, which will make 4.57. That will be wrong. Is it clear? So do not multiply the voltage by any number, even you are trying to balance the equation with any. So as you can see, uh, two more examples. The copper example we already discussed. There's another example, say zinc is reacting with iron 2. Electrode potential for iron 2 to gain electron is minus 0.44, and electrode potential for zinc ion to gain electron is minus point. So both are negative. So if both are negative, which one is a higher value? Minus 0.44 or minus 0.76? So iron is a higher value. The one which is higher value, basically reduction happen. So other one oxidation happen. So when we write the if we use a cell which has having this change in which iron 2 ion is reduced, where zinc atom is oxidized by loss of electron. So what will be the cell voltage produced? It will be reduction minus oxidation. So reduction is minus 0.44, minus oxidation is minus 0.76. So minus 0.44 minus multiply by minus plus 0.76. So when you work out, it will be 0.32 positive. So 0.32. So it means that this reaction is feasible and the voltage produced in this cell is 0.32. But what will happen, for example, by mistake, you took opposite, like you took the first one as a reduction and the second one oxidation, by mistake example. So when I take the first one as reduction, so it is minus 0.76 minus 0.44. So when I solve, I'll get minus 0.32. So if my final answer is negative, if the cell voltage is negative, it means it is not feasible, or this reaction will not occur. So other way around, even you took a wrong reduction oxidation, your answer will come out negative. So it shows that this reaction will not occur. So as you can see, the tendency as more positive, increasing tendency for the species on the left to reduce and act as an oxidizing agent. So because if it is more positive, higher positive value, so the substance which is on the left, it will be a strong oxidizing agent. Strong oxidizing agent means it will have a greater tendency to gain electron, because oxidizing agent by itself it is reduced, and reduction means gaining electron. And same thing, as more negative increases, like it will become more negative, it means the substance will be a good reducing agent, or it will the substance on the right hand side will be a good reducing agent, or it will oxidize, because oxidation is a loss of electron. So higher negative means good reducing agent, higher positive means good oxidizing agent, but on the left hand side, and higher negative means good reducing agent on the right hand side. So if we want to find the more powerful reducing agents, so where we can find will be the most negative end of a series on the right hand side. And if we want a full oxidizing agents, so where we can find in with the most positive electrode end of a series, and they are on the left hand side. Is it clear? Any doubt in this part?